the author link index number 0905458. So the wireless security device I have created is an Android application which is capable of sending UDP flux. The theory behind of this application is that when the device is connected to a remote access point, wireless access point, it extracts the broadcast address of the network, and then inside the while loop, it randomly creates a destination port number, and to that destination port number it sends UDP packets. So the ultimate result is that the remote host forced to send ICMP reply packets. Therefore, the process time for useful applications are reduced, and the remote host is forced to do unuseful things. Therefore, the ultimate results can be denial of service. So, in this Android application, inside this method, using this method, we can extract the broadcast address of the network, and inside this while loop, it generates a random port number which is greater than 1024, and it creates a datagram packet using that randomly generated port, and it sends it. So this happens rapidly. Therefore, it results in a UDP flag. So the basic view of this application is like that. We have a scan button and an attack tooltip. So when we press the scan button, it shows the details of the network, such as SSID and PSSID, like that, MAC address and so on. So why this application cannot be demonstrated on this emulator is that currently the Wi-Fi Android emulator is not supported for Wi-Fi networks. I am always with index number 090324D. Here I have created a Java application to monitor and analyze the packets entering into and going out of the device. JPCAP library is used for this purpose. First, the application lists a number of interfaces that can be used for capturing packets in the device. Here you can see the code. And then the user will be asked to give the number of the interface he wants to monitor. After that, you have to set a filter to obtain the only needed and interested data. So you can see that in the code. Here I will give the interface number as 1, because here you can see the device interface list, and according to my device, the interface which is connected to internet is 1. And then I will set the filter for the device. The filter should be in the format of the TCP dump filter format. And then here you can see the packets that are captured. And let's see. Here you can see some of the packets that are captured. And the packets, so the source address, the destination IP address, and some of the related data and the packet related data are shown here, such as the protocol and the time to live, and some other data are shown, and also the data part of the packet is also displayed here, and the user can also cast the packets as ICMP packet, TCP packet, IP packet, and get the packet specific and relevant information from those. And this tool can be developed for further to monitor a wireless access point or any wireless host. And you can put a proper GUI to further modify the application. Thank you.
package number is 090395T. For the wireless security device, I have analyzed about UDP packets. I have analyzed two methods of denial of service attacks those users UDP packets. The first one is flood attack. In this kind of attack, the network of victim system is flooded with a large number of packets by the attacker to deplete the network bandwidth and thereby making the victim system performance negation or sometimes system crash. Due to saturation of the network bandwidth of the victim system, the legitimate users of the system are prevented from accessing the system. In a UDP flood attack, numerous amounts of UDP packets are sent to either random or specified ports on a victim system. In order to determine the requested application, the victim system processes the incoming data. In case of absence of the requested application on the requested port, the victim system sends a destination unreachable message to the sender, that is attacker. In order to hide the identity of the attacker often spoofs the source IP address of the attacking packets. UDP flood attacks may also deplete the bandwidth of network around the victim system. Thereby the systems around the victim are also impacted due to the UDP flooding attack. The other method is Fragile attack. This type of attack is usually used in Unix and its family of OS platforms as well as in network routers and similar products. There are at least two service ports available. One is Echo and the other one is Sergeant port in this kind of OS or devices. Attacker sends UDP echo packets to the port that supports character generation with the return address spoofed to the victim's echo service, creating an infinite loop. The UDP echo packet that is called as UDP fragile packet targets the character generator of the system reached by the broadcast address. The charger port generates a character and sends the same to the echo service of the victim system. The victim's system echo port then sends an echo packet back to the charger port. The process repeats and generates a loop. Packet generation loop created in this fashion generates damaging traffic and causes severe damage in the system.
Hi, this is Satyavardhan. My index number is Node 9.471A. In this section, we look at a simple program that sends UDP packet over IP network. So let's begin. These are the packages we need to import as we go through. To send any packet, we first need an interface. So here, we get the available interfaces. Network interface and JP capture. Those are two classes that we use to get the available interfaces. Then we list the interface and select one of them. Then we open the interface that we selected by passing the index of the interface. Then we create a UDP packet and pass two parameters as destination port number and source port number. Then we set the IPv4 parameters for that packet. Then we set the data field of the packet. After that, we create a Ethernet packet and set the type of Ethernet packet as IP. Then we set the MAC addresses of destination and source. Then we set the data frame of the UDP packet as Ethernet. And finally, we send the packet and close the sender. In UDP, we don't have any mechanism to check whether the packet has been reached the destination or not. So we just send the packet. and we don't have any mechanism to check that. So that's all about this program. Thanks.
Hi, I'm Rajkumar. Index number is 0904158. Let's have a look at the most important part of this project, the report. The report on wireless network attack tool. In this paper, we are discussing about Wi-Fi networks, their vulnerabilities, the ways of exploiting these vulnerabilities, and the tool developed for this purpose to attack the Wi-Fi network. Under the introduction section, we are giving a brief introduction to our tool. Under the Wi-Fi section, we are discussing about what is a Wi-Fi network and IEEE standards and some terminology that are related to Wi-Fi network. For example, Wi-Fi hotspot and the main advantages of using Wi-Fi network compared to some other networks, and some main drawbacks or some limitations on Wi-Fi networks. So having those information behind us, let's move on some vulnerabilities that are existing in Wi-Fi network that can be easily exploited to attack a Wi-Fi network. So these are the vulnerabilities. Poor security settings, no restricted physical boundaries, physically insecure access points, MAC address filtering, low data encryption, eavesdropping, denial of service attacks, and so on. The way that our tool is going to attack the identified Wi-Fi network or identified Wi-Fi device is basically a denial of service attack. For that, we are using UDP flooding. So, under the UDP flooding section, we are discussing about what is UDP flooding and how can we use this UDP flooding to attack an identified Wi-Fi network. Then, finally, under the attacking tool section, we are briefly discussing about our tool, developed tool. It is basically an Android application which makes a denial of service attack to any wireless device it detects. It may be a wireless hotspot. At first, it needs to detect some wireless device, and then it will connect to one of those devices, and then it will send USB packets periodically for different port numbers each time for that hotspot we are connected. So you know what? This results in the cost system become down. This is how we are attacking identified Wi-Fi network that we are connected to. This is about our